Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. So first let me check my voice and whether I am live or not. Okay, so I'll start with my introduction. Alright, so I think voice, I am live, and let me also check the voice. Perfect. So I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and we were doing indefinite integration. I've already taken one session of indefinite integration from the basics, and today I'll continue the second session. So today we'll learn basic substitutions. Start with the substitution, which is the main thing in indefinite integration. All right. But before starting, let me tell you about the Unacademy subscription also. So as you know, Unacademy is India's largest online learning platform, and you can prepare for many exams on this platform. But let's talk about IIT-JEE. So to prepare for IIT-JEE, you need to take the subscription for IIT-JEE, and once you get the subscription, then you get daily live classes of all the JEE educators. No matter how did you get the subscription, but you will be able to access all the JEE live classes of all the JEE educators, and also the recorded lectures. So whatever, suppose you are starting from the second topic, then you can watch the previous videos, and there are always many courses starting every week. All right, so you can join a new course also. Apart from this, you can attend special classes of educators with on the same platform, Unacademy's app, which is free, so that you can attend without even getting the subscription. So you'll get the feel of the platform, and you can see how to interact with educator during the live session through chat. You can send your doubts during the live session also, or apart from that, you have dedicated doubt sessions also. All right, I mean, you can ask your doubts during the session also, and there are dedicated doubt sessions also. You also get access to live test and quizzes, okay, on the platform. So all combined tests like physics, chemistry and maths combined test, which you give for your preparation of IIT-JEE main level or advanced level. Okay, so all these test series will be available for you, so you will be able to access all these things. All these courses are very structured. That means everything is pre-planned, so you get the information of all the upcoming lectures in advance, with all the details like topics, time, teacher, okay, who is taking that lecture. So this is all about the platform. This unlimited access, I'm repeating, you get once you get the IIT-JEE subscription. So let us talk about how do you get the subscription. You need to download Unacademy's learning app from Play Store. And then you can subscribe for 1 month, 3 months, 6, 12 and 24 months. All right, so you can see these price list is given, so you can subscribe for 12, 24, which are the best packages. So let me talk about these. In these two packages, you can see average price is very low compared to any other. So it is 2250 only average price per month in 12 months subscription, and 1350 for 2 years subscription. But these prices are going to increase soon. Okay, new price list is already out, so I mean, maybe in a week or 2 weeks it will be applicable. Date will be announced soon. I'll show you the new price list so you can compare. So this is the best time to buy. You should go ahead if you haven't not taken the subscription yet. All right, and also you get the 10% discount. These are the discounted price. This you can see is after 10% discount. So you get the discounted price when you use a code. So you can use my code JEET1 to get instant 10% discount. All right. Now apart from this, you can see this is the old pricing, and this is the new one, right? So I was talking about the new price list, which is going to be applicable soon. You can see this 27,000, which is after 10% discount, is going to be 34,650. That too after 10% discount. Okay, so there's a hike, and similarly in 2 years packages also you can see is a hike, and you can see it is now 50,000. Okay, so guys, hurry up if you haven't taken the subscription yet. So this was all about the subscription. Now I will start the session, all right, with definite indefinite integrations, basic substitution. All right, so basic substitution I'll tell you first, and then we'll start the problems. Okay, so we'll do this first question after this. See, all the formulae which we have done earlier, you can generalize those formulae. We have done those formulae when suppose, okay, if you know the formula of fx, I mean integral of fx with respect to x, it is say capital Fx, all right. Then today we are going to learn first that what will be the integral of f of ax plus b. That means when x is replaced by a linear expression ax plus b, right? So you can see b is added and a is multiplied to x. So a is multiplied, then b is added, okay? So we need to find the integral of this, okay, in terms of capital Fx. So see how to do it, okay? In this, we are first learning the substitution. So this part, because it is ax plus b, it is not a, it is not x. So the formula, I mean this formula will not remain same. What will be the change? I'll tell you. So what we do is, we put ax plus b is equal to t, okay? Then you can put t here, but then you have to integrate it with respect to t. So it should be dt here. So you need a relation between dx and dt. So how to form that relation? You'll have to differentiate this, okay? So when you differentiate it, you can write a is a constant, differentiation of x is dx, all right, and differentiation of b is 0, and differentiation of t is dt, okay? Or you can write dx upon dt is equal to, we can differentiate with respect to t, all right? So you'll get this. That means you're getting the relation between dx and dt. So dx is nothing but dt upon a, all right? So this way you can replace dx also in terms of t. So now this integration will become integral of f of t dt upon a, all right? This will be the new integration, all right? So this will be the new integration, and a is a constant. So as I told you in the previous session also, you can take this a outside the integral, okay, and this will be f of t dt. So as now you can apply this formula. It is similar to this. That was f of x dx. Now this is f of t dt. So there is a change of name only. So that is okay. You are integrating f of t with respect to t, and its integral will be capital F of t, all right, plus c. Now you can again replace the value of t. Final answer should be in terms of x. So final answer will be 1 upon a f of, okay, let me write it here. Then final integration will be 1 upon a f of ax plus b, all right, plus c. So now you can compare what is the change now. If you know the integral of small fx with respect to x, which is capital Fx, then integration of f of ax plus b will be capital F of ax plus b, but divided by a. So whatever is the coefficient of x, you need to divide by that number, all right? So that is the change. So in this way you can apply, I mean you can change any formula, you can generalize the formula. So let me tell you the changed formula now. Suppose you have you need to integrate sine of ax plus b, all right, sine of ax plus b. Okay, let me also tell you that it should be ax plus b, not ax square or ax cube or any other function of x. It should be a linear function of x, okay? So you can directly use this. Although this is a substitution, but we are going to memorize this, okay? I mean, we are going to directly, we are going to use it directly, all right? So how to use this? How to use this directly? We know the formula of sine. Formula of sine is minus cos, all right? Sine x, integral of sine x is minus cos x. So integral of sine of ax plus b will be minus of cos of ax plus b. Just put ax plus b, all right, and divide this whole thing by a, all right, plus c. So this will be the formula for sine of ax plus b. So similarly, you can change any formula. Say formula for x raised to n was x raised to n plus 1 upon n plus 1. So you can write ax plus b raised to n, right? So now x is replaced by ax plus b dx. So what will be the answer of this? This will become ax plus b raised to n plus 1 divided by n plus 1, alright? And just need to divide it by a also, so just divide by a, alright? Now it is perfect. So similarly, you can apply any formula. Let me tell you the one of the formula of rational numbers. So we did this formula 1 upon a square plus x square. So that was tan inverse 1 upon a tan inverse of x upon a. Now suppose we have a square plus bx plus c the whole square, alright? Like this. So again you can compare with the same formula, only x is replaced by bx plus c. So how to use it? Now it will be 1 upon a as it is because of this a. Tan inverse of, now x, in place of x it will be now bx plus c, alright, and divided by a, like in the previous formula. And one more thing now you need to do, you need to divide by this number, okay? So you need to divide by this number, so 1 upon b will also be there. So it is now 1 upon ab, alright, 1 upon ab. So I hope all these formulae are clear now. So now we can start. Okay, let me give you one more example before starting. So let's take 1 upon 3x minus 4, okay? What is the answer of this? So we know the formula of 1 upon x. 1 upon x is ln x. So this is also linear, alright? So directly you can apply the formula. So what is the answer of this? 1 upon 3x minus 4 is ln of 3x minus 4, and obviously you can put mod also. In any formula where ln is coming, you can put mod on the argument and divided by 3 because of this number, coefficient of x, okay? So you always need to divide by the coefficient of x. This is the answer, alright? Let me give you one more example. So which formula? Alright, I'll tell you the one irrational, okay? One irrational formula. So formula of irrational functions. So this is, suppose under root of 4 minus, okay, 4 minus 2x minus 1 the whole square, alright? It is written like this. Although it won't be given in this particular form, it will be in expanded form. You'll have to bring it in this form, okay? So that we will learn later. Let's first learn how to apply the formula, alright? So what was the answer of 1 upon under root of a square minus x square? It was sine inverse of x upon a, sine inverse of x upon a. This is a square, right? So a is nothing but 2, alright? Or x is replaced by 2x minus 1. So formula was sine inverse of x, which is now 2x minus 1, divided by a, which is 2, and now you need to divide by this number also, okay? So 1 divided by 2 plus c, alright? So I hope now it is clear. So we can apply. Now we can start solving these questions. So this was very basic substitution. We'll continue this substitution. We'll learn this substitution in detail also today only, alright? So first let us practice some questions. Alright, let us practice some questions in which x is replaced by some number, some other linear function like ax plus b, alright? Alright, so now let's do this problem. How to approach this? You can see it is a product of sine x into sine 3x. So we should apply this formula. Which formula? Cos A cos B. So using 2 cos A cos B, we can we can express this product form as a summation, right? Summation or difference form. So first of all, we'll multiply and divide by 2 so that we can apply formula of 2 cos A cos B, 2 cos x into cos 3x dx. Now apply the formula. So in the beginning, you need to do some manipulation to bring in the form where you can apply the formula directly, alright? So you know the formula of cos, you know the formula of sine, but you don't know the formula of cos A into cos B. Direct integration, alright? But yes, we know how to express 2 cos A cos B in terms of cos of A plus B plus cos of A minus B, right? That was the formula. So 2 cos A cos B is cos of A plus B. So A plus B is x plus 3x, which is 4x, plus cos of a minus b. So cos of a minus b, you can take any function as any angle as a, and this is as b. So 3x minus x is 2x. Even if you take x minus 3x, it will be minus 2x. But inside the cos, it is minus 2x or plus 2x. They are same, right? So it will be plus 2x dx. Now you can integrate, right? Now you can integrate in individual functions. So integration of the first one will be 1 by 2 of, alright. So integration of cos theta was sin theta with respect to theta. So integration of cos 4x will be sin 4x, alright. But now you need to divide by this number 4, alright. Plus integral of cos 2x is sin 2x, and you need to divide by this number, so which is divided by 2, alright, plus c, alright. So this is the answer, simple. It was very simple. So we have similar problems in the beginning. Now let's solve another example. So this is another example. First you need to do some manipulation to simplify this, and then we can integrate it, okay? So alright, you think about it, try to solve it for a minute, then I'll tell you. Alright, so are you trying this? Getting anything? Simplify. Alright, so let's see how to do it. So obviously we need to simplify first of all. Check my voice. Alright, so let me check my voice first, if it is clear. Okay, I think it is better now, right? Yeah, I think it is better, right? Alright. Okay, so now let's simplify this. So where to start? You can see in the denominator it is 1 minus 2 sine square x, right? So first of all, you can write this 1 minus 2 sine square theta is cos 2 theta, so you can write this cos 2 theta, alright. So first let us write this integral of sine 2x plus sine 5x minus sine 3x, alright, divided by it will be cos x plus cos 2x. So cos double of this angle will become cos of 4x, alright, cos of 4x, because angle is already 2, so double of that angle will become 4, so it will become cos 4x, alright. Yes, obviously we can apply this formula cos a cos b, 2 cos a cos b, so denominator will come in the product form, but then you'll have to bring numerator also in product form, alright. So let's see how to do it. First you can pair any two terms here. So I am pairing these two, okay? Why? Because if I pair these two, this will come in the form of 2 cos a cos b, 2 cos theta 1 into cos theta 2, because the formula of sin a minus sin b is 2 sin a cos b form. So, and then this also can be written as 2 sin theta cos theta. So maybe 2 sin x is common, and you might get this factor in the numerator, right? Obviously here you'll get, right, in this in the first term you will get cos x if you take 2 sin common, and if 2 sin is common from this also and remaining is cos 4x, then you can cancel this denominator factor in denominator directly, all right. So let's try that. Let's write 2 sin x as 2 sin x, sin 2x as 2 sin x cos x, plus sin 5x minus sin 3x is 2 cos c plus d by 2. So cos 5x plus 3x by 2 is cos 4x into cos c minus d by 2. So that is 5x minus 3x by 2. So 5x minus 3x by 2 will be cos x only, all right? So now you can see, sorry, to sine, I'm sorry, 2 cos a plus b by 2 into sine a minus b by 2, all right? So this will be sine. This will be sine a minus b by 2. So sine 5x minus 3x by 2 is sine x. So now you can see 2 sine x is common. And now it is very simple, right? In fact, it's a very direct question. So now take 2 sin x common. So only 2 sin x will be remaining, and rest it is cos x plus cos 4x in numerator, and cos 4x cos x plus cos 4x in denominator as well, right? So you can cancel this. And what is the answer of 2 sin x? 2, take 2 outside, and integral of sin x dx is 2 cos x with minus sign plus c, all right? So this is the answer. So I hope it is clear. Now let's try another problem. This is a very good problem, all right? So you try it first, then I'll solve it, all right? First you need to simplify it. See how to simplify this. Simplification is very, very beautiful in this. Shall I do it? It's a very good question actually. Rakshit, it is at 3 p.m., 3 o'clock. 3 o'clock. I was doing quadratic. I've already taken 2 lectures of quadratic. Tomorrow will be the 3rd session. That will be in sequence. Alright, so let's simplify this, alright? See, it is sine 2x, and you know 1 plus sine 2x, 1 plus sine 2x can be written as 1, you can write this 1 can be written as sine square x plus cos square x, and the sine 2x can be written as 2 sine x cos x. So you know this formula, how to use it, right? 1 plus sine 2x, it is sine x plus cos x the whole square. Sine x plus cos x the whole square. So what am I going to do is this, I'll add 1 in this, plus 1 and minus 1, alright? So I can club these two terms, which can be written as sin x plus cos x the whole square, and I'll club these two also, which can be written as sin k plus cos k the whole square, alright? So this first two terms can be written as sin x plus cos x the whole square, and last two terms, if you take minus sign common, then this will be plus only, right? Plus this, so plus 1. So I've added 1 and subtracted 1 in the numerator. So it will be sin k plus cos k the whole square. This whole is divided by sin x, alright, this term plus cos x. So I'm writing this I'm writing in this order, sin x plus cos x minus sin k minus cos k, alright, dx. Now in this you can see this is like a square minus b square type. So you can apply a plus b, a minus b. Let's do it. So it will be sin x plus cos x plus sin k plus cos k, sin k plus cos k. And also second term will be sin x plus cos x minus sin k minus cos k dx, and this whole will be divided by sin x plus cos x minus sin k minus cos k. All right. So you can see this denominator is cancelled now, right? So it was very easy. Now remaining expression, you can integrate all these terms. Okay, this is a constant. Last two terms are basically constant. All right. So let's split this integration. So first it is sin x dx. The second it will be cos x, integral of cos x dx, and sin k plus cos k is a constant, so you can take outside this sin k plus cos k as it is outside, and it will be integral of 1 dx. All right. Now just write the answer. So integral of sin x is what? Minus cos x. Integral of cos x is what? Sin x. And integral of 1 is x. So write this sin k plus cos k. I hope this point is clear to everyone. Don't do the mistake here. Plus c. Sin k and cos k are constants with respect to x, because you are integrating with respect to x, not with respect to k. If you are integrating with respect to k, then it won't be a constant. Alright, so let's continue. Another problem. This is again a very simple problem. In fact, this you can do directly. Let's see if you can do it. Obviously, whenever you have irrational terms like this, you first rationalize it, okay? So let's rationalize it. Let's rationalize it and see what is coming. So we'll multiply and divide by under root of 3x plus 4 plus under root of 3x plus 1, all right? And in denominator, it will be now a square minus b square. So it is now 3x plus 4, 3x plus 4, a square minus b square, which is 3x plus 1. So x will get cancelled in denominator, right? And only constant will be remaining, and that too 4 minus 1, 3, all right? 3x and 3x you can cancel. So this 4 minus 1, 3 you can write outside 1 by 3, and it will be, I mean, you can distribute integration. So you can write 3x plus 4 raised to 1 by 2, all right, dx. And second will be integral of 3x plus 1 raised to 1 by 2 dx. So now you need to apply the formula of x raised to n. Only the x is replaced by ax plus b. So as I told you, just apply the same formula. In place of x, it will be ax plus b, the final result, and the whole thing should be divided by a only, all right? In this case, a is 3. So answer of first one will be 3x plus 4 raised to 1 by 2 plus 3 by 2. 1 by 2 plus 3 by 2 is 1 by 2 plus 1, sorry, which is 3 by 2, divided by 3 by 2, which you can write 2 by 3, all right? And minus of, and also divide, you need to divide by this 3 also, right? So one more 3 will come, all right? And then integral of this is, this 1 by 3 was already there, okay? So I'll write it outside only. Then again you'll apply the same formula here. So 3x plus 1 raised to 3 by 2 divided by 3 by 2. So that is 2 by 3. And this divided by a. A is also 3. So I hope you're getting it. So now you can see 9 and 9, this is common. So 1 by 2 by 27. 9 into 3 is 27, will be outside. And then answer is 3x plus 4 raised to 3 by 4. Sorry, 3 by 2 minus 3x plus 1 raised to 3 by 2, all right? So what is the answer? Answer is which one? The first one, all right? So A is the answer. Okay, so let's do this. Is again a very good problem, all right? So try this one. Try this. This is a very good problem. Simplifying this expression is actually very tricky, but you can figure it out. You can figure it out. Think about it for a minute, then I'll tell you, right? Think about it for a minute, then I will tell you. How to start? Obviously, numerator you can apply cos c minus cos d, so it will be in terms of product. But how to simplify denominator? That is the main point. of this question. How to simplify denominator? All right, so now let me tell you, okay, if you have given a thought, see, what am I going to write? What I'm going to do is this. If I multiply and divide by cos theta or maybe sine theta, if I multiply it by cos theta, cos of some angle, I don't know which angle, so that it will be cos theta here and this will also be 2 cos A cos B, then what is the formula of 2 cos A cos B? It will be cos of A plus B plus cos of A minus B. And after doing that, I'll get two terms here, right? Two terms here and one more extra term, which I have multiplied actually cos theta. So overall, it will be three terms. And nothing will get cancelled because you're getting cos of A plus B plus cos of A minus B, right? If it would have been cos of A plus B minus cos of A minus B, then we can think that cos theta and that negative term might get cancelled for some theta, all right? Okay, then let us think about some formula in which we get minus sign in between first of all. So only one is remaining. You have already tried cos theta, now you should try sine theta, all right? So if you multiply by sine theta will be here and sine theta will be here. We'll decide theta later. Then what will be the formula after expanding it? 2 cos A sine B or 2 sine A cos B. Read it like 2 sine A cos B. So it is sine of A plus, okay, 2 cos A sine B, if you read it, then it is sine of A plus B. So sine of A plus B, so which is 5x plus theta minus, in this formula you get minus sign, so minus of sine of 5x minus theta, all right? Now to cancel these two terms, right, to cancel these two terms, angle should be equal, okay? So this angle is theta and this angle is 5x minus theta. So if these two angles will be equal, if theta is equal to 5x by 2, right, 5x by 2, I hope you're getting it. So now we have got, and after cancelling this, we will be left with only one term of sine. And in numerator, if you multiply these, if you apply cos C minus cos D, then it will be again in the form of product of two terms. So that one term which is remaining in the denominator might get cancelled, okay? So that is the main point. So now we have got a clue. Multiply and divide by sine of which angle? Sine of half of this angle, okay? If it is 7x, then multiply by sine 7x by 2. If it is 9x, then multiply by sine 9x by 2, okay? So that is the main thing. So multiply by sine 5x by 2, okay? Simultaneously, I am applying cos C minus cos D also in numerator. So that will be 2, cos C minus cos D is 2. Sine C plus D by 2, so that is 15 x by 2, all right, into sine C minus D by 2. So sine C minus D by 2 is sine D minus C by 2, I'm sorry, cos C minus cos D, all right. 2 sine C plus D by 2 into sine D minus C by 2. So sine of, it will be 7x minus 8x, so it will be minus x by 2, all right. So minus you can write outside, minus you can write outside, all right. Now in denominator, what are you going to get? Although I have simplified it here, but I'll write it again. Sine of 5x by 2 plus 2 times of cos 5x into sine 5x by 2, all right? In this, we are going to apply the formula. Okay, so I'll write it again. Minus integral of, so it is sine 5x by 2, write all the terms as it is. Sine 5x by 2, write 2, and sine 15x by 2 into sine x by 2, all right? And what is the, okay, 2 cos A, apply this formula 2 cos A cos B, so it will be sine of 5x by 2, and 2 cos A sine B is, as I have applied it here, sine of A plus B, so sine of A plus B, so 5x by 2 plus 5x by 2, 5x plus 5x by 2 is 15x by 2, right? 15x by 2 minus sine of 5x minus 5x by 2, which is 5x by 2. That was the purpose actually. We have already discussed it, okay? We multiplied and divided by sine 5x by 2, so that we'll get these two terms cancelled. Okay. All right, and see this sine 15x by 2 is also getting cancelled, right? So we'll cancel these two terms also, numerator and denominator. What is remaining? So whatever is remaining, again apply the formula of 2 sine A sine B. So 2 sine 5x by 2 into sine x by 2. So you can express this product as a summation, all right? So I'll write it here, minus of 2 sine A sine B. So what is the formula of 2 sine A sine B? 2 sine A sine B is cos of A plus B. 2 sine A sine B. So cos of A minus B, cos of A plus B minus, 1 minute, sorry. 2 sine A sine B. So it is cos of A minus B, so which is 5x by 2 minus x by 2 minus cos of A plus B, so which is 5x by 2 plus x by 2, all right? Cos of A minus B minus cos of A plus B plus C plus, okay, no, we haven't integrated yet. So minus of, it will be finally 5x by 2 minus x by 2 is 2x, so cos of 2x, all right, minus it will be cos of 3x, so cos of 3x, all right? So this is what we'll get. Now integrated. So integration of cos 2x will be, minus is already there, this minus, all right, this minus. So minus of cos 2x, integration of cos 2x is sine 2x by 2, and minus of minus, this will become plus. So cos of 3x is sine 3x by 3, all right, plus C. So this is the answer. So I hope it is clear. So this was the answer. It was a very good problem. Now let's solve another one. All right. See how to do it. This is a very famous problem. I think you can do it. Try it for a minute. Harsha, are you there, Harsha? See how to split. How? If it is in the numerator, then you can do it easily. You can apply 2 sine A cos B, the formula of 2 sine A cos B, and you will get it as a summation, right, in the form of sum of two expressions, defactorization. But let's see how to do it. In such integrals where you have two terms of sine, or one sine, one cos, or two terms of cos in denominator, then always check that difference, either difference or sum of the angles will be constant of those two terms. So check the sum or difference. So you can see, yes, first angle is x minus a and second angle is x minus b. So their difference is x minus a. Take difference of these two angles. So difference is nothing but a minus b, or if you write this ahead and this before, then sorry, this is b minus a, or it can be a minus b also, all right? So using this difference, you can multiply, read this denominator as sine a cos b, all right? So I am going to multiply it by sine of a minus b or cos of a minus b. Why sine of a minus b? First of all, a minus b is constant, so sine of a minus will be constant. Second, cos of a minus b will also be constant, But which one we need to multiply or divide, sine or cos? Okay, so whatever will solve our purpose will multiply, right? So what is our purpose? Purpose is to, split this. So if I multiply by 2, I multiply by cos A minus B, then after expanding it will be cos A cos B, cos A cos B, and plus sin A sin B. So if you divide by these terms, then yes, in one of the term cos will cancel, and in other term sine will cancel, and in numerator also you'll get only two terms, right? So yes, we need to multiply it by cos, but if you multiply by sine, then what will happen? Then if you multiply by sine of A minus B, it will be sine A cos B. So this whole thing will get cancelled after dividing, right? You'll get 1, okay. But the other term will be sine B cos A, and nothing will get cancelled, and that will be again a complicated expression, right? So sine of A minus B will not work in this case. What will work? Cos of A minus B. So cos of x minus A minus x minus B, okay. Write this. And what are we multiplying? We are multiplying by cos of B minus A or A minus B. Doesn't matter. Inside the cos both are same. Okay, so after multiplying this, let's see what will happen. Now, you write cos of B minus A, which is a constant. Expand the numerator, okay. Apply the formula of cos of A minus B. So it will be cos of x minus A into cos of x minus B plus cos A minus B is cos of A cos of B plus sine of A sine of B, right? So sine of x minus A into sine of x minus B, all right, divided by sine of x minus A into cos of x minus B, all right, dx. Now divide, and then you can separate. So cos of B minus A, and if you divide, then first integral will be, let me put the brackets, first integral will be, see, this cos will get cancelled, and you will be left with cot of x minus B. Fine, we know the integration of cot, all right, plus, we know the formula of cot. And in second, sine will get cancelled, this term will get cancelled, right? And it will be sine upon cos, say with same angle, so it will be tan of x minus B, all right, dx. So now you can apply the formula, so it will be 1 upon cos of B minus A. Okay, now just directly write the answer. So integral of cot theta is ln sine theta, right? So ln, or you can write minus of ln cosec theta. So I'll write ln of sine theta. So ln of sine x minus B. So x, in place of x, it is x minus B. So you just need to divide by 1 only. So that means it's perfect. Plus the formula of tan theta is sec theta, right? ln sec theta. So it is ln of sec x minus B, all right? And we have got the answer. So this way you can integrate this, okay? So whenever you have two terms of sine or two terms of cos, you need to, two terms of cos in denominator, then you need to multiply by sine of A minus B. Make sure A minus B is constant, all right? But when you have one term of sine and another term of cos in the denominator as a product, then you need to multiply by cos of A minus B, right? And divide by cos of A minus B, and make sure A minus B must be constant. So that will be there, okay? In that way you can split the terms. I hope you have got it, right? So now let me tell you substitution, all right? So now let's begin the substitution. So the previous substitution which I have told you about ax plus b, that was very basic, and in the similar way we are going to substitute now any other function, all right? And whatever possible we'll try to remember the formula, but not in all the questions you can do it directly, all right? So in question to question you'll have to substitute different functions, okay, to bring this in a form where you can apply the formula, all right? So let me explain this. Now listen to this carefully. Suppose if we know the antiderivative of small fx, if integral of fx dx is capital Fx. So I'm taking the same integral which I have taken in the previous session and always, actually everywhere. The same function is integral of small fx is capital Fx. This is known, okay? This is given. We know this formula, all right? But we need to find the integral of f of gx. Now you can see x is replaced by some other function, but g dash x is also there. G dash x is also there. If it is so, then we can directly apply the formula of f, right? Directly how? Directly you can write the answer. So let me first tell you the answer. Answer of this is nothing but f of gx, all right? F of gx. So this is something which you can directly use, all right? So whenever, okay, let me repeat. If you know the formula of fx, small fx, all right, dx, you know the integral of fx with respect to x, and you need to find the integral of f of some other function into derivative of that function, meaning f of gx into g dash x. Then you can directly apply the formula of fx. So it was capital Fx, so it will be now capital F of, but x will be replaced by gx, okay? So it will be capital of f of gx. That's it, plus c, all right? That's what actually we did in the previous question also. See, it was in the previous substitution, it was f of ax plus b, right? Ax plus b. So its derivative of this was a. It was not given. So a can be multiplied and divide. So you can divide and multiply by this, right? Now this you can read this as f of gx. This is gx into g dash. So formula, what is the formula? Its formula is capital F of ax plus b. And how did we get this a? Because we multiplied and divide by a, right? To make this derivative, right? To make this derivative. But in all other functions, you can't multiply and divide by derivative. It should be given, because here in this case, in the previous case, when it was f of ax plus b, derivative of ax plus b was a constant, so that's why we could multiply and divide by a, and the number which is in the division we can take outside the integral. But if it is not a constant, if it is g dash x, which is a function of x, then you can't multiply and divide, because if you divide, you can't take that number outside, and that will be there in the denominator, and you won't be able to apply this formula. So I hope it is clear. Now let me explain the substitution first, okay? So what we have done, how did we reach to this point, okay? What we have done is we have put gx is equal to t in this, okay? So if we put gx is equal to t, we know the formula of f of x, but it is f of gx, so we are putting gx is equal to t. Only thing which we need to learn, to notice, is that g dash x should be there, okay? This should be our main focus. If we are putting gx is equal to t, then we need to focus on g dash x, whether it is there or not, all right? So now we can differentiate this with respect to x. So g dash x dx, derivative of gx is g dash x, d of gx you can write as g dash x into dx, all right? So I have differentiated this equation. So it is g dash x dx is equal to dt. If you don't know this type of differentiation, then let me explain it here. If you are having gx dx, all right, gx is equal to t, then see how did I get this? I am differentiating this with respect to x, with respect to t, sorry, with respect to t. So I am applying this operator both hand side. Now this is d of gx, right? D of gx is equal to d of gx upon dt is equal to dt upon dt is 1. So now you have taken dt right hand side. So it is d of, sorry, let me write it here. D of gx is equal to d of, all right, can you see it? All right, so it will be like d of gx is equal to dt. Okay, I'll write this step here. So this was d of gx upon dt is equal to 1. This part will become 1, right? So you multiply it by, so you'll get this. So directly you can write this, okay? Directly you can write this. All right, let's come back to this. So now we'll get, after substitution, just replace this gx by t. So it will be f of t and g dash x dx by dt. So write this dt. So you have reached to this point, f of t dt. That means f of x dx. So integral of this will be capital F of t plus c. and again replace t by gx. So gx was value of t was gx. So answer is f of gx plus c. All right, this is the answer, which you can use directly. All right. So let me show you how to use this directly. First of all, we'll try to first we'll learn how to use it directly. All right. It is going to help. It is going to save a lot of time. All right. So in all the examples, I'll tell you both the methods. For example, first I have the integral of, say, e raised to x square into 2x dx. All right. E raised to x square into let me not give you 2x. All right. It is x only. All right. It is x only. Now you know the formula of e raised to x. All right. You know the formula of e raised to x, but it is e raised to x square. So that means you can't apply that formula directly. So it is like e raised to gx, then you need g dash x. If you have g dash x, you can apply the formula of e raised to x, right? So what is g dash x? What is the derivative of x square? It is 2x, but you have only x. So it's okay. You can multiply and divide by 2, no problem. So now you have got e raised to gx into g dash x. So what is the answer? So directly you can write 1 by 2 of answer is e raised to x square plus c. Okay? So this is the one way to directly write the answer. Okay. Now, if you don't want to do it directly, then what you will have to do? So I'll do it separately. Then in the other case, you'll have to take x square is equal to t. Okay. Take x square is equal to t. Then differentiate this. So you'll get 2x dx is equal to dt. All right. Then substitute. So now you know 2x dx ko you can write dt. So it will be e raised to t dt, and this 1 by 2 is there because you have multiplied and divided by 2. So that step is same. Okay. Multiplying and dividing by 2. Then you can write 1 by 2 of e raised to t plus c. Now in the final step, you'll have to again replace by t. Okay. So 1 by 2 of e raised to x square plus c. So if you learn this direct application of the formula, then you can save these many of the steps. So at least a few seconds you can save, okay, in easy questions. So, okay, let's practice it. We'll practice some more questions and I hope we will be able to learn it. Right. So now suppose we have tan square x, the whole square, divided by 1 plus x square. Can we apply the formula? Compare. If this is g, then 1 upon 1 plus x square is g dash. All right. So I'll write it like this. Tan inverse of x, the whole square, all right, into 1 upon 1 plus x square, all right, dx. So if you put tan inverse x is equal to t, this whole thing is going to be dt, right? So it is going to be t square. Then integral of that will be t cube by 3, all right? If you directly compare it, then it is f square into f dash. So you can apply the formula of x square, right? Just replace f by x. So it is x square. That means you need to apply the formula of x square, which is x cube by 3, okay? So if I directly write the answer, the answer is tan inverse of x whole cube by 3, all right? So I hope you are getting it. So let me change some formulae. Directly, let's write the formula first of all. Okay. Think about it. Suppose I have f dash x upon x. Okay, you can you can memorize these few terms as a formula. Okay, few integrals as a formula. So f dash x upon fx. If I take fx is equal to t, then f dash x dx will be dt. It is dt upon t, right? So fx is a function. We know the integral of 1 upon x, right? And f dash x is there with dx, right? So that means integral of this is going to be ln of f of x, all right? Directly you can memorize this. F dash x upon fx is ln fx, all right? Same thing you can do with any formula, okay? Let me write some other formula. If you have f dash x upon 1 plus f square x. Now which formula is this? If you put fx is equal to t, f dash x dx will be dt, and it will be dt upon 1 plus t square. So that is tan inverse of t, right? That means it is tan inverse of, now t, what is t? T is nothing but fx, okay? So if you have f dash x with dx, you can apply the previous formula, okay? Just assume f as x, all right? And apply the formula. Okay, in your mind just assume f as x and forget about f dash now. F dash is gone with dx, it is now dt, all right? Similarly, suppose you have all right, e raised to fx into f dash x. What is the answer? Answer of this is e raised to fx plus c. This is very useful, okay? The next, which I'm going to tell. Now whenever you have, do you know the integral of 1 upon root x, okay? Memorize it, although that's the same formula, x raised to n, all right? If you bring it into the numerator, it will be x raised to minus 1 by 2. But because 1 upon root x is very useful, it is very frequently used, so just remember the formula. It is 2 root x plus c. Okay, using this for example, if you have integral of f dash x upon root fx, then what is the answer? Then in this case answer will be 2 root fx, okay? Directly you can use this. That means you're putting fx is equal to t, f dash x dx will become dt. It will be dt upon under root of fx, so 2 root fx, all right? So for example, you have integral of say cos x upon under root of sin x. Now do not confuse with the derivative on integral of sin, all right? Here it is f and this should be f dash. Perfect. Derivative of sin is nothing but cos. So it is f dash x upon root fx. So you can apply 2 root fx, all right? So answer of this is nothing but 2 root sin x. 2 root sin x plus c. So I hope it is clear. Let's do one problem. Let's do this one. See how to do it. It is integral of 1 upon x, 1 upon ln x into 1 upon x into dx, all right? So what will be the answer of this? Whose derivative is what? Whose derivative is present? So obviously ln x, derivative of ln x is present. Derivative of ln x is 1 upon x. So that means this is f dash into dx, right? And what is this? 1 upon f. So what is the integral of 1 upon x? That is ln x. So what is the integral of 1 upon f, where f dash x dx is present? Ln of f, right? So answer is this ln of f. F is also ln x. It's okay. Put ln of x, all right? Plus c. That is the answer. And if you are not getting it, then do this thing. Put ln x is equal to t. Then differentiate it. So you'll get 1 upon x dx is equal to dt, all right? Then replace this number by dt. Do the substitution and write this complete integral again. So 1 upon t and 1 upon dx will become dt. Then write the answer ln of t plus c, and then resubstitute the value of t. So that is value of t is ln of x. So you have reached to the same point, all right? You have reached to the same point, all right? So I hope it is clear, right? Solve one more problem. Can we do it directly? Compare it. Do it fast. It is tan x raised to n into sec square x. Just focus. Whose derivative is given? That is the main point. Whose derivative is given, all right? Clearly you can see sec square is the derivative of tan, right? So this is f dash, right? And this is f raised to n. So that means you need to apply the formula of x raised to n, right? If you put f is equal to t, f dash x dx will be dt, it will be t raised to n. So answer is going to be tan x raised to n plus 1 divided by n plus 1. You can write it directly, all right? Plus c, right? Or if you're not getting it, then substitute tan x is equal to t. This is called substitution. Tan x is equal to t. Then differentiate it. So it will be sec square x into dx Differentiation of tan x is sec square, differentiation of x is dx, and differentiation of t is dt. All right. So this will become dt, then write this complete. So in boards, obviously you'll have to write all these steps, but in competitive exams, you should learn this trick, okay? Directly use it, directly write it. It will save your time. So it is t raised to n dt, and then apply the formula. In boards, you'll have to write it. You'll have to write this, all these steps, okay? Then put the value of t. So t is now tan x raised to n plus 1 divided by n plus 1, all right, plus c. So this is the answer. Let's do one more problem. Let's try this. Think about it for a minute. This is the last problem, all right? This is the last problem. Think whose derivative is sine 2x? Whose derivative is sine 2x? All right, so if you don't know, sine 2x is 2 sine x cos x. I hope you have done it. And 2 sine x is cos x, 2 sine x cos x is derivative of sine square x, which is 2 sine x cos x, all right, 2 sine x cos x, as well as it is also the derivative of cos square x. The only difference is of sine. So it will be minus 2 cos x into differentiation of cos x is minus sine x. So minus I have already put, all right. So only minus is there. So you can write, because in denominator you can see cos is given, cos. So you can put minus sign and put one more minus sign here. So it is minus of 2 sine x cos x. All right. So this is f dash. Whose derivative is this? Cos square's derivative. So 1 plus, write cos square x the whole square, all right, dx. So this is your f, this is your f dash. So which formula you need to apply? Just forget about this. It is 1 upon 1 plus x square, right? Read fx is x square. So 1 upon 1 plus x square is tan inverse of x, right? So it is minus of tan inverse of x. What is your x? X is your cos square. So cos square of x plus c. And if you are not able to do it still, then you can take cos square x is equal to t, then differentiate it. So you'll get 2 cos x into minus sine x into dx is equal to dt, and then you can substitute in this integral the value of cos square and dx. So it will be dt, this whole thing in the numerator will become dt upon 1 plus t square, and minus is also there. Then you can write minus of tan inverse of t, then resubstitute the value of t. So final answer will be minus of tan inverse of cos square. All right. Harsha, are you in class 11th or 12th? D. Harsh. All right, so we'll continue integration in our next session. Slowly we'll increase the difficulty level of substitution. First we should be comfortable in such small problems where you can see derivative directly, and if you can figure out derivative of f with dx, then you can directly apply the formula if there's a standard formula. But it won't be the case in all difficult type of problems. You'll have to actually put fx is equal to t, and then you'll have to substitute in the question, and then you might have to simplify it, okay, after doing so. Okay, so we'll learn all those things later in the upcoming sessions. All right, keep practicing. We'll continue in our next session. All right. Harsha, I teach in Mumbai, but now I have started on Unacademy. So taking this session at 7 p.m. for class 12th students, and one track I have started at 3 p.m. for class 11th students. And where are you from? All right, so, all right, Andhra Pradesh, good, all right. Have you done integration? Have you done integration? Yes, I am from IIT Kanpur. I did my graduation from IIT Kanpur. I give my introduction in the beginning of the session. You can, if you watch any of my video on this channel, I have given, yeah, differentiation method. All right, not properly. All right, so you can watch these videos. You can attend these sessions, uh, live sessions, or you can watch it later if you're not free. All right, I'll complete this indefinite integration. I'll complete this indefinite integration and then definite and then complex numbers for class 12. So this is what I have planned for, these three topics so far for this month. Let's hope. All right. Nice talking to you, Harsh. See you later. Next session.